All right, howdy chemists. Hopefully you enjoyed the titration lab and got to experience more titration elation than frustration. As I've said before, you joined a small but incredibly wonderful and nerdy group of people who have titrated and got to experience the frustration of trying to achieve the perfect pink. So just to kind of review what titration is, I know you've already done it, but just to kind of reinforce that. Titration is a technique where you use a solution that you know the concentration of. Either you've been told or you know its concentration because you made it up yourself. And usually often that's through molarity. So you know how many moles per liter, how concentrated one solution it is, and you use it to figure out the concentration of an unknown solution. So in our lab, we used the known concentration of sodium hydroxide to determine the concentration of some various acids, such as just what's the concentration of vinegar, the acetic acid in vinegar. Specifically, we were looking at acid-base titrations, which are really common. That means you're going to know the concentration of either the acid or the base, and you're going to use that then to solve for the concentration of the other. And acid-base titrations are based on neutralization reactions. Acids and bases neutralize each other, often to make water. So we have a basic neutralization reaction here. Acid plus base makes water, and then often an aqueous salt that may still be dissolved in the solution. So for example, we had our sodium hydroxide as our base, and we were neutralizing the acid, acetic acid, and that made water, and then sodium acetate was our aqueous salt. And there's kind of a general diagram that both fits ours and kind of titrations in general. So we have our base here of known concentration. So we know its molarity. So for example, it might be like 0.4 molar. So 0.4 or 4/10 of a mole of sodium hydroxide per liter. But what we don't know is the concentration of this acid. We know how much of it we have. We know its volume, which we need to determine its concentration. What we don't know is how many moles. And so what this then becomes is a type really of stoichiometry. So we add base to our acid, and we know that we've neutralized it when we see that lightest color change possible, because we're going to have our phenolphthalein in here and it turns the light pink. And then we can use how much base did it take, volume of base. How much base did it take? And we can essentially translate that into moles of acid. Once we've done that, we can solve for molarity. Remember, molarity is moles per liter. So if I know the volume of acid that I start with, really my question is, how many moles are in there? And I'm going to answer that by, well, how many moles of base did it take? So this is a type of stoichiometry. You'll remember our earlier types of stoichiometry tended to follow this basic pattern. Mass to moles of substance A to moles of substance B, and then often back to mass. Mass being a measurable quantity. So that's from our previous ones. Titrations use molarity, so it's a measurable quantity, but here it's going to be liters, or the volume of our base. Though it could be that you know the concentration of your acid. It just so happens that our known is the base. So liters is a measurable quantity. That's something I can measure out with a graduated cylinder in the lab. And then convert that into moles of base using the molarity of the base. So I do have to know that. You can't titrate an unknown with an unknown. But once I know the molarity, I can take the volume of the base that it took to neutralize the acid, and now I know how many moles of base that I added. Then I can use the equation, the stoichiometric relationship, so that would be the coefficients, to go to how many moles of acid. And sometimes that's a 1-to-1 ratio, and sometimes it's not. So it is important to include this step where we look at the molar ratio between my acid and base. And then we actually, for titrations, usually stop there, because then once we've done, I want this part, once we've done this step here, that's going to give us moles of acid, and now we can calculate the molarity or the concentration of the acid. So let's look at a problem that's not directly from the lab, because I know you practiced several titration problems in the lab. So if 40 milliliters of 1.5 molar sodium hydroxide is required to titrate 15 milliliters of HCl, that's our acid, what is the molarity of the acid? So here's our base, sodium hydroxide. Here's our acid. We know the concentration of the base. It's provided in the problem, 1.5 moles or moles per liter. The question is, what's the concentration of our acid? And remember, to solve for concentration, we're really saying what's its molarity, right? So molarity is moles of HCl divided by liters of HCl. So we actually know the volume already. It's up here. We started off with 15 milliliters of HCl. So that's what we would have gathered into our pipette, 15 milliliters, and then we put it into our sample. We measure it really carefully. So that number is going to be the number I used right down there. I do need to convert it into liters since molarity is expressed in moles per liter, and you could do that within your problem, or you could do it first. I'm going to go ahead and do it first just so it's done. So I'm dividing this number by 1,000. So I move the decimal place 1, 2, 3. And I'm going to keep those zeros back here so I remember that they're significant. Our leading zeros are not, but trailing zeros are with the presence of a decimal. So in the end, that's going to be my volume. So in order to calculate the molarity of my acid, I need to figure out how many moles of acid were present in my solution. When I measured out 15 milliliters of HCl in my pipette, how many moles of acid were there? The only way to do that would be to titrate it with a known concentration, a base with a known concentration. So I added little drops of sodium hydroxide until it turned the lightest pink I could achieve, and it took 40 milliliters to do that. So really, the question I need to ask is, if it took 40 milliliters of sodium hydroxide to titrate, to neutralize my acid, how many moles of acid were there? So I need to go from volume of base and convert that to moles of acid. So you might want to pause the video right now and see if you can solve the rest of it on your own, now that you've done some examples with your lab as well. So my volume of my base is 40 milliliters of sodium hydroxide. But before I can use this concentration to go from liters into moles, I do need to convert to liters, because that's the language of my conversion factor. So there are 1,000 milliliters in a liter of sodium hydroxide. Now that I'm in liters, I can use the molarity. So 1.5 moles of sodium hydroxide in every 1 liter. And that number right there, so first of all, I can tell from my units that this cancels out. This number is coming from a given concentration. If I hadn't been provided that number, I could not solve the problem, because I wouldn't know how many moles of sodium hydroxide I had, therefore I wouldn't know how many moles of HCl it neutralized. Now, if I stopped and did my math right now, what I would have essentially answered the question would be, how many moles of sodium hydroxide are there in 40 milliliters if it has a concentration of 1.5? But remember, that's not my goal. My goal is to be able to answer this. What's the molarity of HCl? So I need to know the moles of HCl. So my last step here would be to use my equation, the molar ratios in my equation, to convert to moles of HCl. And it happens to be a 1-to-1 ratio, but I'm going to include it anyway so that you're sure of what I'm doing, because it's not always a 1-to-1 ratio. In fact, you can really expect to at some point see one where it's specifically not. So 1 mole of sodium hydroxide. So every 1 mole, or think of it as like 1 particle, every 1 particle of sodium hydroxide can neutralize 1 mole or 1 particle unit of HCl. So if you're taking a look here at my units, you should see then that they cancel out. And units is a good way to kind of check your work. Milliliters cancels out, liters cancels out, moles of NOH cancel out, moles of NOH cancel out, and I'm left with what I'm ultimately kind of trying to figure out right there. I'm going to stick with this color because I like it. So when I go through and I go to do the math, I see that there are not very many moles of HCl in that sample. But that's not my final answer, because the question is, what is the molarity of the acid? So in order to do that, I'm going to take those moles. So there's 0.060 moles of HCl in my 15 milliliter sample, but I'm going to want that in, want that in liters, because my ultimate goal is to answer the question, how many moles per liter are there in my sample? And when I do that and consider my sig figs, I see that my acid has a concentration of 4 moles per liter, or 4.0 capital M. And so I used the concentration of my base to determine the concentration of my acid. So how much base did it take relates to how many moles of base there were, which relates to how many moles of acid there were. And once I know how many moles of acid there were, I can solve for the molarity, moles per liter. So as you are prepping for future assessments, practice makes permanent. So see Canvas, the Unit 3 module, for an extra practice worksheet on titration. And as always, if you're having questions or concerns, send me an email or visit with our SI. And I'll see you guys soon.